Good morning, everyone. Thank you for taking the time to join us this morning in a discussion with ourselves, Osperity, and AWS about cloud technologies and machine learning in the energy industry. So I'll introduce myself, and when Ed Epstein, Senior Systems Architect at AWS, comes on in a few minutes, I will allow him to introduce himself. So I'm Paul Ritchie. I'm the Chief Operating Officer of Osperity. Osperity is a leader in intelligent visual monitoring for industrial applications throughout North America and Australia at this point. And what we're going to do today is I'm just going to give a brief overview of what Osperity does as an AWS-based technology in the industrial space, this specifically focused on our energy market, and then really allow Ed to speak to some of the services that we use to work with our clients and provide them that true management by exception. So without any further ado, we'll get started because Ed's section's probably far more interesting than mine. Anyways, so Osperity is a cloud-based intelligent visual monitoring platform, and we use cameras at the edge as our data collection point. So those are our sensors, our visual sensors. And what Osperity does is works with clients to understand the anomalies or the exception categories that they want to be alerted to as more and more of these locations become unmanned. So whether it's around vehicles or people or equipment, animals in some cases, we're able to alert them extremely quickly through the combination of our edge device and our technology that sits within AWS. So this is an overview of our platform and how it works. So on the edge, we're using the cameras to capture that data, which in turn sends it to our edge device, or as we call it, our cloud bridge. And that cloud bridge runs a quick analysis and says we're 50 to 60% certain this is an exception that the client wishes to be notified of. Then that imagery is sent to the cloud where the deep dive computer vision AI is applied to that imagery and then determines to whom and when and how it is to be delivered to them. So there's multiple means of delivery and source data that can be sent to them based on what their requirements are. We can also in turn take this data and export it or deliver it to other software platforms through API or a direct connect. And we can also bring in sensor data and provide the same management by exception rules to, temperature, vibration, gas monitoring, so on and so forth, and provide that alerting that cooperates with the visual and then delivers a nice unified alert to the client. Just give you a few areas that we work in the energy space. Right now, as an organization, we have 54 unique clients in North America and Australia. That accounts for right around 1,000 cameras in the field across 260 sites from, South Texas to the Northwest Territories to the outback in Australia. So it's important for us to have a cloud-based system so we're able to create instances in country when necessary for the most efficient delivery of our system. So when you look at some of the different types of analytics, and I won't get into too much depth, but give you a brief overview. When you look at operational efficiencies, it's, where can we take people out of the equation for risk, for productivity and time management, for actually being able to provide a true visual from a third party as far as an inspection goes. And these are a couple of examples. So when you look at the top left under operational efficiency, that's a 100,000 barrel tank with a floating roof. What we're actually doing there is eliminating the need for someone to go up when there's snow to determine the snowpack level on that roof. So we're taking the person out of the equation and alerting when it hits a certain point. Now, a lot of people say, well, wouldn't there be a sensor on that floating roof? There is, but it's at the inside on the bottom. It's not measuring the depth of the snowpack on top, which is necessary for both weight and safety, because if the snow is higher than the top of the tank, obviously it's going to come over the edges. Other areas are being able to remotely manage by visual recognition simple assets like a pump jack that an operator would normally attend on a regular basis throughout a week. They can now manage more assets and be able to pay attention or send the right people to those assets should they have a problem. So instead of getting a SCADA alarm and then running out to see what's being done, they may still get that SCADA alarm, but then have access to our platform to be able to see exactly what is occurring. From the environmental perspective, we do a lot of work around clean and dirty water and the ability for people to remotely monitor the activity there and be alerted to certain activities. In this case, one of the activities they're alerted to is the ability to validate the truck that's there is supposed to be there, so we tell them that. They then in turn, through the alert, go onto our platform, and through another system, they turn the pump on to be able to allow them to haul the water out. We also work with thermal or IR imagery as well, in this case determining whether flares are on or off, alerting to various temperature thresholds, as well as smoke and height of flame and direction of smoke. So in many jurisdictions now, that's becoming a very important factor. And with visual, you get that truly defined exception when you go outside, or in some cases beneath what the regulations are. From safety perspective, understanding the activity and where people are they in hazardous zones? You know, do they have their Scott Air Pack on because there's H2S present? Inspecting Class 1, Div 2 areas where there's high risk in the sense of large generation buildings and such, taking the people out of the equation and alerting on different anomalies that occur there. One of the other things that we recently launched that's not necessarily analytics based, but what it is doing is actually increasing the knowledge base of our machine learning models, is the ability for us to deliver autonomous inspections of multiple points of an asset. So in the case of this, it's a tank farm that has 3 100,000 barrel tanks, and with 5 cameras, we're able to produce their internal daily inspection as well as their twice weekly regulatory inspection for their energy commission. So we are providing that data autonomously that's sent to them when they want it with the images they desire. So on a daily basis, that saves the company's operators 3 hours, where we deliver it at the time that they require it. Now, how does that build our machine learning data set? Very simple. We're collecting more data to be able to start to train on the anomalies that they want to know on these particular assets that perhaps we wouldn't otherwise garner for them. When you look at, who we're dealing with, we are right across the breadth of the upstream, midstream, and downstream spaces within the energy sector. We also have clients in the construction, mining, and utility spaces. One thing that makes us, very unique in the ability to deliver these industrial visual analytics is the exceptionally large data training set that we can autonomously train these models by. So on that note, we'll get into sort of how we do things with AWS, and we'll turn it over to Ed Edstein. He's just going to put up his presentation now. As we do that, if you do have any questions, you can just put them in the commentary section on the commentary chat section on here, and we'll address them at the end as a group. There we go. It's all yours, Ed.
Thanks, Paul. Can everybody see my screen appropriately?
Yes, sir.
Excellent. So let me just really quickly introduce myself. So as Paul said earlier, my name is Ed Epstein. I am a solution architect with AWS, and I'm based in Vancouver, so Western Canada. And I work primarily with startups like Osperity. And what I'm going to talk about today is why AWS for the energy industry, and then talk a little bit about the way we see our relationship with our customers when we go to build services, and then specifically I'll talk about some of our video recognition services that we have that help to drive the service that Osperity provides. So why AWS for the cloud, I guess is the, or sorry, for energy, I guess is the question. And really, AWS really is the leading cloud in the energy industry. We have the broadest and deepest platform of any cloud provider that can really solve any customer problem. Every year we launch over 1,000 new services and features. In 2018, for example, there were over 1,400 new services and features launched. And as a result of that, something that we'll look at on the next slide is AWS has been the leader in Gartner's Magic Quadrant for 10 years in a row now, both for ability to execute and also for completeness of vision. And specifically in the energy industry and with oil and gas, we have the most oil and gas domain experience, a dedicated oil and gas team, and obviously a wide range of oil and gas partners and ISVs, Osperity being one. Annika is another partner that works with oil and gas customers. ClearScale, Moxa, Nuvera would be some other examples. And we also have a culture of innovation, and this is something that I'll talk about in an upcoming slide as well in more detail, but we work backwards with our customers to understand their business problems and then provide solutions for that. And that's the same way that Amazon and AWS has built its services over the years, by working backwards from customer needs. In terms of the size of AWS, we have a global footprint, so 77 availability zones. That's in 24 different geographic regions across 42 countries around the world. So we can help customers go global really just in minutes. They can take the infrastructure they've built on AWS in one part of the world and very quickly and easily deploy it to other parts of the world as they need. We also adhere to a very comprehensive list of security and compliance controls. NIST, ISO, PCI, SOC compliance is a big one, HIPAA compliance in the healthcare space. So any kind of compliance regime, that not just global ones, but ones that are specific to different regions, countries of the world as well, like Pipeline Canada, for example. AWS has a really comprehensive set of security and compliance controls. And then one of the things that you'll hear us say very often is that there's no compression algorithm for experience. Um, we have over 13 years experience as a cloud provider, the longest of any cloud provider out there. And as a result, we've been able to take that experience and offer the highest operational reliability of any cloud provider. Something that we're obviously very proud of. As I mentioned earlier, for the now 10th consecutive year, AWS is the leader in cloud in Gartner's Magic Quadrant. Again, I think this is really heavily tied to that no compression algorithm for experience background, because we took all of the things that we had already learned from running the Amazon.com e-commerce site, since 1995, I believe, and took all of that learning and experience. And when we went to build AWS, we applied that there, and as a result of that, our ability to scale and all of those learnings really shows in the way that we can provide that reliability and that feature set to customers. And the driving force behind that has to do with the culture at Amazon Web Services. And one of the things that Jeff Bezos, our founder, has said before is, for a lot of technology companies, they'll start with the software that they want to build, and then they'll have their engineers go and build that software. And then once it's built, it's handed off to the marketing department, and the marketing department actually looks at marketplace and then figures out how to sell that. And what we found is that actually doesn't really work all that well, because if you start from customer needs and work backwards, and you're going to build something that really is much more effective at meeting those customer needs. And so our working backwards process does exactly that. It starts with the customer, and identifies who is the customer, what is the customer problem, what's the customer benefit if we build this service. And in order to guide us, we take all of that information, and before we start developing the service, we write the press release and ask ourselves, if this is what the press release of this service is going to look like, is this going to get customers excited? Is this going to solve their problem and be the right thing for their needs? And then we iterate on that so that we can be very confident in saying that if this were the press release for this service, yes, it will meet those customer needs. We also write an FAQ to understand what kinds of questions customers will have about the service that we're developing, so that we can identify if we've missed something, or there's a customer need that we didn't make apparent when we're writing the press release. And then as we develop the software and we write the user manual, that working backwards approach, starting from the customer, the end result is a service that really meets the needs of customers. And that's something that that working backwards approach that Amazon Web Services takes very seriously, and we know that when we use it, we get the best results for customers. So on that note, let's talk a little bit about Amazon Recognition, which is a service that we developed to do deep learning based image and video analysis. So what you can do with Amazon Recognition is you can feed it video, and it will apply machine learning and extract information from those images and video. So it will identify people, it will identify objects, it will identify activities. And of course, a video is really just a sequence of still images. And so we can apply those algorithms both to still images and to video. And it also has a very wide range of items that it can pick out in that video. So I mentioned faces. It labels objects, flowers, vases, and picks out text and activities and paths. So if you think of Osperity's platform, for example, and where recognition can sit in that slide that Paul showed earlier, it can identify when a person enters a particular frame, if that person is moving towards something, a piece of equipment, if they've arrived at that piece of equipment. It can identify text. So if you see a truck pulling up next to a piece of equipment out in the field, and that truck has a logo on it, it can identify what that logo might say, the text on the truck, say the truck identification number. So in terms of what it provides out of the box, the kinds of things that that customers want to be able to do, it provides that. In addition to labeling the items and pulling text out, it also provides a confidence score. So it will tell you if, with a certain amount of confidence, the things that's identified, like skateboard, automobile, person, the road in this case, and then taking those percentages, feeding into a system that can raise alerts based on the probability that something is happening in a scene. It gives the ability to have a very fine-grained control over what might be something that needs human attention and needs looking at, and what might not be, to minimize the kinds of scenarios where you have false positive alert, for example. One of the key functionalities that that recognition provides is the ability to add custom labels. So there are many things that recognition already knows about out of the box, common objects. We talk people, objects like cars, text, and so on. But in some cases, there are types of things that recognition might not already know about. And for those scenarios, it gives customers the opportunity, like Osperity, for example, to develop and train the machine learning model to recognize objects that are specialized, essentially. So specialized to a particular industry, for example, like energy. And so what that allows recognition to do is to pick up these specialized objects and identify them based on the training that's been done. So, like I mentioned, it could be a logo on the side of a truck. It could be a physical object out in the field, like a particular thing you saw in Paul's slide, the gas flare coming off of a stack there. So the ability to be trained and to learn custom models is really where recognition is able to help customers that have industry-specific needs. And then finally, we have a huge global community of energy partners. And so, I mentioned a few earlier, like Onica and ClearScale and Moxa, for example, but you see here, there are many, many more that in a wide range of industries, like IoT, compute, monitoring, all kinds. And so that broad customer base and the experience and the size of the ecosystem that customers get when they're on AWS is something that we feel very confident is something that you get only on AWS. So that comes to the end of my presentation.